Hello, everyone. Great that you're still here. So the fact that light is beneficial for mental health is well established. And so we use light therapy not only for seasonal depression, for instance, but we use it transdiagnostically also for major depression, bipolar depression, Parkinson's even, and it's also applied for eating disorders. So I'm very grateful to Professor Swab for already hammering this point home. That is very important for us. What we typically do is put patients in front of the light box. And the question I want to ask today, so I'm more of going to ask questions rather than give you answers, is should we be doing more? Could we be doing more or better than just putting patients in front of the light box? And so I'm here probably because I am the supervisor, or one of the supervisors of Emma. Emma is investigating the ways to optimize light therapy for people with depressive symptoms. We're doing this together with University of Leiden, so we're colleagues there, Nikki and Georgiana. And this is important research because actually we know that it works, light therapy, we don't know really why it works. There's a lot of hypotheses about the phase shifting effect of light therapy being effective. Maybe it's the shifting of sleep, or maybe it's the phase angle, maybe it's a strengthening of the circadian system. There's also a possibility that it's not via the clock, not via the SEN, but rather direct effects implied. But we don't know really, and so this is very important. But if I'm not mentoring Emma, I try to be in the field. So this is the field, right? I'm not necessarily in the field in grass, but this is my field, real world investigation. So I study what effects of light are on human functioning indeed. And so we're very proud owners of this light logger. I'm also wearing one. It's not as a demonstration, I'm actually a participant today. And we're very happy with these light loggers because they don't only measure the visual light, or the amount of light that's important for the visual system, but they also try to estimate the melanopic EEI, so which is the amount of light that is relevant to the IPRGC, which projects to the SCN. So we think it's important for the biological activation. So we're very happy to have this. We're using this in Emma's study as well. We'll be using it soon. We're also using it in Rose's study on the NICU, and we're using it on all our participants. But before I was doing light research, I was already involved in studying the effects of nature on human well-being. And we call this nature's restorative effects. And when we talk about restorative, we mean that it helps restore people from stress, from low mood. And nature has been shown to have these wonderful effects in many different studies. So we have shown that there is improved mood, that there's reduced physiological stress when people are exposed to nature. And this can be visuals of nature, or actually being in nature, of course, which is always better. They show increased cognitive functioning, increased functional brain connectivity, particularly in the attention networks, and even faster recovery after surgery. So, of course, when people go into nature, they are always almost exposed also to light. So a couple of years ago, we thought, wouldn't it be nice if we could really untangle these effects? Because maybe people are doing so well in nature because they're receiving light, or maybe people who are receiving light are doing so well because they are exposed to nature. So we performed this study where we had an experience sampling. We collected from people with lower and also higher scores on the BDI or on the SEL. We have them here as two groups. Basically, we studied them as a continuum because they are really a continuum. So we asked them to keep this experience sampling, and they were logging in what type of environment they were. They were filling in a checklist that helped us estimate how much daylight they were seeing and they were exposed to, how much nature they were exposed to. So we could statistically untangle those and also measure stress, rumination, mood, etc. And I'll go very quickly through this. What we found was that both nature and daylight have an independent effect, a beneficial effect on both. So we saw that vitality was higher for everyone, both as a result of being exposed to nature and of being exposed to daylight. So this was only natural light that we were measuring. We saw more positive effects and less tension if people were exposed to nature and to daylight. This effect was there for everyone, but the effect And it was on nature exposure was stronger for those with low mood or high tension and anxiety. And we also saw that being exposed to daylight was better for their for stress, lower, it results in lower stress. And this was again trended to be stronger for people with more symptoms, depressive symptoms. But that still leaves unanswered the question, what is it in light that does this? And of course, being a psychologist, we also, so I'm very much involved in studying the biological effects and the effects by a biological clock, but there may also be psychological pathways perhaps. And perhaps even for a day like this is the case, because people do show a very strong preference for natural light. We know that field studies show that effects of sunlight on depression, a daily walk is good, but all of these combine a more intense photon exposure, if you will, with also seeing sunlight, seeing the sky. So could there be also a purely psychological pathway to being exposed to light? And of course, in order to do this, well, number one is you think, why would this happen? And if you look at the theories that try to explain why nature is good for us, there's various aspects to this. It might have an evolutionary aspect in terms of survival. It might have a richness, a fascination in it. But all of these ring true also for daylight effects. And we see that it's much preferred, and it has very special spatial and temporal characteristics. So we thought maybe we can try to find this psychological pathway if we keep the amount of photons exactly the same and only manipulate this spatial play of light. And one of the most fascinating plays of daylight is in so-called dappled light, is what you see here. And we did a study where we projected this dappled light with a projector, so not the real thing. We projected it on a wall and saw that stress, people were in a stress induction, and the stress built slower and to a lower extent if people were looking at the dynamic display of this pattern of light. Now, of course, you can then argue maybe it's because there was some distraction, there was just something happening, some stimulus in the environment. So we then went a little bit deeper, and we investigated this video. It's a video of dappled light. And what we did was we tracked where the dapples of light go, and we then simulated this so we could exactly replicate the movement, which we call natural movement, or we could do this in a non-natural, so in an artificial way. We also played with the edges that could be soft or hard, with the gradient that would be there from bright to dim on the sides. And so we created simulations, 16 of them. So we manipulated movement, soft edge, gradient, and the shape. So shape could be perfect circles, this is sort of artificial, or the original shapes. And then we added also the original video, a still from the original video, and a uniform light. And we then projected these on a wall like this, and then asked people to report on them. In separate goes, we had people report on how natural they felt this was, and also how much they felt it would restore their stress if they were stressed. So, for instance, if this was a waiting room. And so here you see 19 circles, and they immediately demonstrate how close those two are. So something that looks more natural is also believed to be more restorative. And we actually see this is reported stress restoration, but we also see this in actual stress restorations when we induce a stressor. Interestingly, if you look here, this was a uniform surface. So this was just a white wall, basically. And you see that a number of those perform a lot less. You see here the static real image. So this was the real dappled light, but only a still. And this is the real video. Those down there at the top were our artificial movement, which was, to be honest, very terrible. But they were all worse than having just a white wall. So it's not just movement, it has to be natural movement. If you then go to natural movement with hard shapes, like circles, or we call them blobs, but they were the original shapes, we did a little bit better, but still worse than the still from the real dappled light. And then if we added some edges or a gradient, it got better. But actually, really, if we did everything, only if we did everything, it got close, very close to the real video. So it really needs to be very natural to be very restorative. But this, and this is not the ultimate proof, but it does illustrate that there might be a psychological pathway also. And I think it's something we recognize. If we are outside and the sun suddenly bursts through the clouds, there is this feeling of awe, of inspiration, of that we all appreciate this. And of course, it's the warmth of the sun on our skin, etc. Okay, so there may be a psychological pathway to light. But if you look further into effects of sunlight, and I was again very happy to see some of the slides of Professor Strapp, who was showing that there are these latitude effects on health. And there's many of them in lots of different diseases. Already in 1915, we established that people who were working indoor were suffering far more from cancer than those working outdoors. In 1941, we saw that in northeast of the US, people were dying of cancer more frequently than in southern states. This is repeated over and over for many different types of diseases, so cancer, multiple sclerosis, Alzheimer's disease, asthma, autism, diabetes 1, and of course also depression. Now we can say maybe this is the clock at work, maybe this is indeed photoperiod. But if it's photoperiod, we still don't know which part of the light spectrum is at play. And of course, if you look up many of the epidemiological studies on latitude effects, they will not so much talk about the clock, but will talk about vitamin D and UVB exposure. And so UVB exposure is crucial for our vitamin D production. We cannot produce vitamin D ourselves. It's a hormone, but it's the one that we don't produce ourselves. We need either to take it in orally, from food a little bit, but mostly from light exposure, or we take the drugs, of course. And of course, vitamin D is a very important hormone for us. It reduces risk of cancer, cardiovascular disease, schizophrenia, bipolar, etc. So you want to have enough vitamin D exposure, of course. There's a lot of evidence for the importance of latitude. So if you go up higher in latitude on the northern hemisphere, you will see that many of those diseases increase in, often this is tied to vitamin D and sunlight, UVB to be specific. How much UVB are we actually getting, and how much vitamin D do we have? Well, we measure this only from the 20-hydroxy vitamin D, and this is what we typically have, and this is what we need. There are different opinions on how much we need, but they start roughly here. And so what you see is that we are not getting nearly enough. How come? Well, number one, because we get fat in winter, but that's a long story. Also, we're spending a lot of time indoors, almost 90%. It's between 87 and 93% that I've seen estimates. We wear clothes, and so this is also a campaign for shorts and skirts, because effective vitamin D synthesis, of course, requires that you expose your skin to the sun. And of course, because we live at this latitude. So between the months of September to April, so in winters, we simply don't get enough UVB exposure, even if we were outside. So UVB is very important. However, so if you see those latitude effects on lots of diseases, including depression, then they are very robust. If you, however, look at studies that have tried to test this with vitamin D supplements, those effects are far less robust. And this can have various reasons. Number one, it may be difficult to adhere to taking the vitamin D. It may also be because you don't, so when you take in oral vitamin D, you don't have the same metabolites that you have if you were exposed to light on the skin. So there's many more metabolites that also have a very healthy effect. It may also be that vitamin D is just a bystander and there's something else at play. So if we look at the sun's radiation, so the yellow one is a perfect black body. The sun is almost a perfect black body. The orange is what the sun is giving us. So the colored part is what you see, what we here on Earth experience because the atmosphere filters out apart. And you see that there is ultraviolet and visible light, but half of the energy coming from the sun is actually in the infrared and near infrared. And so near infrared provides 30 megajoule to a day to the body. It interacts with virtually all of our cells, and we speak of the optical window into the body between 600 and 1,000 nanometers. What does this mean? It means most of the light that we experience stops at our skin. Vitamin D goes a little bit into the skin, but near infrared, so dark red and near infrared go into the skin, and they can travel inches into our bodies. They can even go through the scalp. So we see that now this dark red and near infrared are being used in what is called photobiomodulation therapy for lots of different afflictions, but particularly also for depression. And it's effective. So there's a red, it used to be a laser, now we also use red LEDs that we put for a few minutes, up to 15 minutes sometimes, to the skull for a couple of times, and people say that they feel relief from this, that they report lower depression. There's also effects on pain relief, wound healing, etc. But the interesting part on the depression is that it can work both transcranial, so indeed if you put it to the frontal lobe, but it also works systemic, so if you put it on softer tissue of the body, it appears to be just as effective. This is one of the first meta-analyses performed, but it's been shown that it increases blood oxygenation and blood flow in the brain. It reduces neuroinflammation and oxidative stress, which are, especially the inflammation, is very much implied in depression, and it restores energy homeostasis because it's the mitochondria that absorb this. So this optical window in the body appears to be very relevant. It's the window between 600, so where the red starts and where it becomes invisible to us and becomes near infrared, where it's not just warm. So, however, it is a little bit difficult. The law of reciprocity doesn't really hold. So for a part, it's the more the better, but then it's a bimodal relationship. After some point, you've reached the optimum, and then more gets to be less effective. So the question that I wanted to bring today is, yes, the topic logs is important to measure, and we've been doing this for ages. We're now measuring melanopic EDI for human exposure because we are aware of how important this biological clock is, and the IPR-GC signals to the clock. But we spend, as I said, around 90% of our time indoors. And what we're doing is artificial light is being hinged to not have any UV and not have any infrared or near infrared, because that's a loss of energy. Incandescent light used to have infrared, fluorescent lighting and LED do not. Windows block UV light, and we are now developing and installing more E-windows, which are also blocking infrared. So we're basically shutting ourselves off from the majority of the sunlight that we evolved under. So we're ignoring 90% of the solar spectrum, and I know that we have to also be careful, too much UV, but there's also something to be said for being careful to not miss all of the UV, and perhaps even the near infrared. So as I said, electric lighting doesn't have this at all. Windows block UV light. What about our light therapy? Well, light therapy is done with electric light, fluorescent or LED, and is typically offered in a box. And what's also very evident is that it's typically advised to be used indoors, or at least it's sort of suggested that we should be using this indoors. And to be honest, my own research has also involved a lot of light from a box. We've even tried those therapy glasses, which really try to trigger only the IPRTCs. And our light loggers that we're so happy to have and are so proud of are only measuring the luxes and the mEDIs. There is an infrared sensor there that I'm going to use, but I think I've been looking in a too limited fashion at light. Even if we don't call it officially light, if it's UV or near infrared, sunlight might have beneficial effects on health status by yet unclear or not as solidly established ways as the IPRTC activation, and also the psychological mechanisms. So I would like to vote for considering its full spectrum, timing, its temporal and spatial variability as the most healthy deadline. Thank you very much.